Good morning. My name is Vince Fuller. This is a short presentation that came out of a conversation that a few of us had a couple months ago during a meeting. Those of you, the gray hairs and the no hairs among you, may recognize the mid-'80s movie reference. The rest of you probably will have no idea why all of the author names are John. So what's this all about? 240/4 is a chunk of address space that was originally and still is defined as reserved for future use. It's basically 1/16 of the total address space, or 6.25%, that's set aside for future use. Well, given that the IPv4 address space is running down, well, maybe it's time to start considering using that which is reserved for the future. Okay, I didn't think that was funny, but so basically the title of the talk is "The Future Is Now." So there are several different ways you could go about using this space. The first is obviously throw it into the public use pool, which makes it potentially available sometime in the future for general use. Of course, since implementations need to be modified to accept these addresses, that's not something that you can do tomorrow. Second option is make the space, private use address space, just like another chunk of RFC 1918 space. That's what Draft Wilson Class E01 talks about. Jeff Houston's one of the co-authors. He can answer questions about that. Or you could split the space up between those two uses or find some other special use for it. Or you can do nothing, which is basically what we've been doing now and what we seem to do a lot of in the internet industry. The approach that the authors took, after some argument, there's actually some people in our little group that argued very vociferously for making it private use, some that argued that no, you can't do that, some that invoked all sorts of economics arguments on how you should make this a commodity or set the price on it or whatever. But the one thing we could agree on is that we've agreed to disagree, but it'd probably be a good idea to make it possible to use this space sometime in the future. And the approach that meets all of our interests was simply to make the modifications to implementations to allow this space to be used, and then let the community decide over the next year, 2 years, whatever, how they want to allocate it. And so let's do it. Let's make the code changes. The code changes are actually very simple. Basically, 5 different files need to be modified on a Linux implementation, a couple lines each. The spec is about 5 pages long, including all the IETF boilerplate, so there's probably only about two pages of actual text. Feel free to read it. As I said, there is some running code. I did some changes to Linux to make it work, both for Linux, the two different types of kernels, one that's running on the Linux boxes and one that's running current Linux. Again, 5 files, removing a few lines each, basically. One of the files you don't even really have to modify. It's a definitions file. You could easily come up with a binary patch for this. Dino, my colleague, has on the Lisp test platform, which you may hear a little more about later in the day, has actually done similar changes there. Again, the changes are very simple. Took maybe an hour to code and test and get working. Turns out that FreeBSD actually already supports use of 240/4 unmodified, with one exception, and that is that if the FreeBSD box is acting as a router, it won't forward something that uses these addresses. It considers them Martians for forwarding, but it's happy to let you configure them as interface addresses and use them as a host. As I understand it, OS X is based on FreeBSD, so it should work, and some testing that we've done indicates that it does accept 240/4 addresses quite handily. Obviously, this doesn't talk about the largest deployed base of PCs, Microsoft Windows, so some appropriate patch would have to be made for that and distributed. It will take time to get this in the field. It's not something you could turn on tomorrow, but the sooner we get the code changed, the sooner people might be able to start using it in the future. That's it. If there are any questions, I'll be happy to take them. Any comments, I'll be happy to take those too.
Randy Bush, IIJ.
Randy, yes.
Just want to underscore a lesson here.
Yep.
Don't hardcore code address crap in routers, hosts, etc. Look at that for v6, please. ULA, all this nonsense. Don't do it.
That's probably some good advice. Anyone else? Is that a question, or are you just walking up the hall? Okay, then I'll wait.
I'm Rob Seastrom, and I'm one of the collaborators on Draft Wilson.
Sure.
We kicked this back a lot, probably as much as you guys did, and in view of the fact that I have very recently run an HDSL network where we had to strenuously avoid last octet 0, last octet 255, to deal with obsolete Microsoft crud that's a decade or more old that's still out there in the field. I believe that there is a very serious chance of big operational troubles for our call centers and stuff like that if this sort of thing goes out and becomes public as opposed to private address space.
And I actually would agree with you. However, and in fact, this draft is agnostic on whether it should be public or private. It's just saying, let's make the code changes. I think that's actually a really good argument for only using these addresses in a new build or at a private network where you control all of the end systems and you don't have to worry about legacy junk out there.
We also talked back and forth about just how dire the warnings attached to it should be. And
right. Right. We can talk about that for days. But my point is just let's make the code changes and see what we can do.
Absolutely, 100% agreement.
Good. Is that it? Okay, I'm done.